Number 6, Erica's swimming due north at a rate of 7 feet per second. So, okay, 7. If the current of the lake is 3 feet per second in the direction of south 75 west. Okay, so south 75 west. So right here is 75. This is 75 degrees. Find Erica's resultant speed and direction as a true bearing. Okay, we can do this. So there's our vector, 7. And then 3 feet per second. So this is the current vector. And so let's see, let's get our angles. The first one would be 90 degrees. So we would have 7 cosine 90, 7 sine 90, and that would simplify to what's the cosine of 90 degrees? 0. So that's actually 0 and 7. And the next one is we got to find the angle. So we got to go from here all the way to here. If that's 75 and it's supposed to be 90, then that's 15 degrees. So 180 plus 15 is 195 degrees. So the other one is 3 cosine 195, 3 sine 95. That's B1, B2. Adding B1 and B2 together, you get negative 2.90 and 6.22 is what I got. And when you take the magnitude of V1 plus V2, you take negative 2.90 squared plus 6.22 squared. You know the drill. You should get 6.86. So the 6.86, and it was in feet per second. All right, so that was the resultant speed, and direction is tangent over 6.22 over negative 2.90. Second quadrant, so we'll worry about that in a second. Tangent of 6.22, inverse tangent, divided by negative 2.9. I got negative 65. And then I'm going to add 180 degrees, and I get 114. Hang on. Did I do something wrong? No, the theta is in our trig 114.9. Oh, that would just be 115 if I'm rounding. Okay, now 115 degrees. We have to give it a true bearing. So that's got to come from the north. It's crazy, isn't it? So let's see. 90 and about 115 here, right? So this is 25, right? So we're everything but 25. So 360 minus 25 is 335. So the true bearing, theta, equals 335 degrees. So watch out what it asks for. It asks for the true bearing, which means it comes from the north again. Remember, this one. Okay? So that was number 6.